Hello everyone. Uh, Today I'm going to talk about the modeling project that we did regarding the curtain drain applications in the on-site wastewater treatment systems. I would like to acknowledge the Ohio Department of Health who provided the funding for this project. And this is the team, the project team that was involved with the project. Dr. Larry Brown, who is a professor and extension in ag engineer at the Ohio State, and I am Vinayak, who primarily acted as a project coordinator, and then we had a big group of students, graduate students, who helped us do most of the modeling work. The overall objective was to evaluate the performance of curtain drains. How effective are they in terms of removing the excess soil water from the on-site wastewater treatment systems? As most of you are familiar with these systems, you typically have a leach trench or two adjacent trenches, and we're installing curtain drains at a certain spacing to keep the natural water table below these leach fields. Now, uh, once in a while, what's going to happen is, as you have precipitation events and so on, this water table is going to come up, and the objective is to keep that water table as far away as possible from the leach trenches. Once in a while, it's gonna pretty much try to mix up with the wastewater that's coming out of these systems, and to avoid this for most of the days, we have laws and specifications for designing these systems. So the objective is to bring that water table as far below as possible as fast as you can with the curtain drains. Now, the water table that I showed here is just an illustration for simplification. In real life, this is how the water table is gonna look like between the two drains. It takes a elliptical shape in the field. Now, this is a typical on-site wastewater treatment system. You can see the curtain drains are about 15 feet from each other, and the trench, the leach trench itself, is about 2 feet deep, and then the curtain drains are placed at about 4.5 feet deep from the surface. Now, what we did was we modeled two drain spacings between the curtain drains. So these are 15 feet and 22 feet, and about 6 depths of curtain drains. So we started at 1 foot below the surface, which is not a practical scenario when it comes to designing these systems. But we started from 1 foot, and we used 6 inches of increments on drain depth. So 1 foot, 1.5, 2, 2.5, and 3 feet. And then we also considered maximum profile depth of that particular soil, or 6 feet or about 200 centimeters, whichever was the minimum. So about 6 depths and 2 spacings make up for 12 combinations of depth and spacing. We also simulated a no drainage scenario. So altogether we have 13 scenarios. Then what we did was we used drain mod N2 which is a simulation model, particularly for agricultural drainage systems, but it works well with any situation where you have two parallel drains. So we modeled about 66 different soils in Ohio, and each soil was simulated for all those 13 scenarios or depth spacing combinations I mentioned. And we used about 30 plus years of weather record to come up with our results. And the main output from drain mod that we are interested in is the depth of water table from the surface. Now what we did was, when we got the water table depths from the model, we summarized all the model outputs for that entire 30 plus years simulation period, and the summaries are they are available in the form of number of days, average number of days based on the 30-year record, that the water table would remain within the first 1 foot from surface, and this is number of days in a year. So average number of days in a year out of 365 that the water table would remain within the first foot of a soil. And the same way we have results summarized for number of days the water table was about 1.5 feet from surface. And then we also have summarized results for the water table that was between 0 and 60 centimeters from the surface. And we also summarized results for the water table to remain in within the first 2.5 feet from surface, and the last one was for about 3 feet from the surface. So now I'm gonna show you a demonstration of how the results have been summarized. Before that, I would like to give you the contact information if you have any additional questions regarding this. The primary contact person would be, I'm assuming, Rebecca, who is program manager for the sewage treatment systems program at Ohio, at ODH. And if you have questions regarding our modeling or the statistical summaries, you can contact me or Dr. Brown. Alright, with that, I'm gonna switch to this folder. When you probably get the results, you're gonna see these 3 files, and the first file that is more of an interactive spreadsheet for you is a summary of all soils with utility. Now this is an Excel file, and it has some code written in it in using Excel macros, so make sure you enable the content